Hello everyone, my name is SN Patil. In this video lecture, we will discuss topic right circular cone. Here we discuss how to find equation of right circular cone and example on right circular cone. Let us see what is right circular cone. Right circular cone is a surface generated by straight line and passing through a fixed point and making a constant angle with line through the fixed point. Now see, these are the generator. These are generator, that is the line, and all the lines are passing through this fixed point that is called as a vertex. Okay, and all these line passing through also a guiding curve. It may be a circle, ellipse. Okay, and this is the fixed line that is called as a axis. The fixed point, this is the fixed point, is called as a vertex of the cone. Now here the constant angle with a fixed line and this generator, okay, is called semi-vertical angle of the cone. This is the semi-vertical angle. And this fixed line is called axis of the cone. Okay. Now let us see how to find equation of right circular cone. Here we find the equation of right circular cone whose vertex are alpha, beta, gamma and semi-vertical angle theta. Axis the line, symmetrical line is here. So first we draw the diagram of the vertex. See, this is the fixed point. Suppose A point and the vertex are given alpha, beta and gamma, and all these lines means these are the generator. Okay, intersect also guiding curve. This is the guiding curve and this is axis of the cone. Suppose this is a B point and this is the semi-vertical angle theta. Okay, and see the denominator of these symmetrical lines means this is the axis of the lines. These are the DRS, direction ratios. Okay. Now here we have taken the fixed point vertex as a alpha, beta, gamma vertex of the cone, and we take here P be the any point on the cone. AB is axis of the cone. See, this is the equation of the axis of the cone. Now DRS of the AP means direction ratios of the AP is x minus alpha, y minus beta and z minus gamma, and DRS of the axis L, M, N. Okay, and theta is angle between the axis and the generator AP line. Okay, now here we use the concept is suppose there are two vectors. Suppose this is A vector having component A1, A2, A3. Okay, and the second vector is B bar vector. Component is B1, B2, B3, and theta is angle between them. Then here we find the cos theta is equal to the dot product between two vectors A bar dot B bar and divided by its magnitude. Okay, when we simplified this dot product, then A1 into B1 means I bar dot I bar is 1, that is A1 into B1. Similarly for A2 into B2, A3 into B3 and divided by the magnitude of that vector, that is A1 square, A2 square, A3 square, and the magnitude of B bar vector is B1 square, B2 square and plus B3 square. Okay. Now similarly here the AP is suppose vector. Okay, and x minus alpha, y minus beta, z minus gamma, these are the component, and this is the another vector, suppose b bar, and these are the component. So here the a1, a2, a3 are the component we consider are the DRS. Okay, and we apply the formula here, then cos theta is equal to L into, suppose this is a1, a2, a3, then a1 into b1, a2 into b2, a3 into b3, and divide by their magnitude. Okay, so which is a required equation of the right circular cone. Okay, now let us discuss the particular cases if the vertex of the cone is origin, means this alpha, beta, gamma 0, that is a point 0, 0, 0. Suppose this is equation 1, put alpha, beta, gamma 0 here, what we get? We get cos theta is equal to, cos of theta is equal to, here alpha, beta 0, simply Lx is remaining. In second term, My is remaining. Third term, Nz is remaining, and divide by under root L square, M square plus N square. And here, simply X square plus Y square plus Z square. Okay. Now here, squaring both side and denominator we multiply to the cos theta. Then we get squaring both side, the square and square root cancel. We multiplied this denominator to cos theta. That is L square, M square, N square, okay, into X square plus Y square plus Z square is into cos square theta is equal to Lx plus My plus Nz bracket square. So this is required equation when vertex of the right circular cone at a origin. Now second case, vertex is origin and axis along the z axis. Now this is the axis, this is the axis, and which is z axis, means suppose see, this is z axis, okay, z axis, this is x axis, and this is y axis. So here these are the vertex of the cone, that is the origin. Okay, that is, this is the a point 0, 0, 0, and z axis is axis of the cone, so that the element here, the DRS becomes 0, 0, 1, means L is equal to 0, Y is equal to 0, and N is equal to 1. We just substitute here the value of the element because we already calculate the equation of the cone, right, circular cone whose vertex at origin. Okay, just we substitute here L equal to 0, M is equal to 0, and N is equal to 1. Okay, then what we get the equation? We get here simply L, M, N. N square means 1 square is 1, and here the x square plus y square plus z square into cos square theta, and in right hand side element 0, and here N is 1, simply z square is there. Okay, now here we construct the z square. Cos square theta is multiplied x square, y square, z square. Okay, to every term. Now we put this z square into cos square in right hand side, and here x square plus y square is remaining, x square plus y square, and cos square theta is common, and we put z square into cos square theta, z square into cos square theta in right hand side. Okay, so here we take z square is common, and in left hand side what is remaining? X square plus y square into cos square theta, and here if we take z square is common, 1 minus cos square theta, and we know 1 minus cos square theta is sin square theta, and here cos square is divided, sin square upon cos square is tan square. We get x square plus y square is equal to z square into tan square theta. Okay, so this is the second particular case where vertex at origin and axis is z axis. Okay, similarly, if there is a axis is y axis, then L is 0, M is 1, and N is 0. If axis is x axis, then here L is 1, M is 0, N is 0. Okay, now let us see the example on this right circular cone. Here vertex is given and axis of the line and semi-vertical angle is given. Okay, so first of all, here we draw the diagram. So we get the idea. Now this is the vertex. Suppose this is A point, 1, -1, 2. Okay, and here this is the guiding curve. This is the generator. Okay, generator, and this is the theta. The axis of the line is given. The denominator are the generator. That is, generator is 2, 1, -2. Suppose this is the B point. So axis AB, and take P be the any point X, Y, Z. Okay. So here we write the given data. So we have the axis. Let axis of the cone X -1 divided by 2, Y +1 divided by 1, Z -2 divided by -2. Okay, therefore the DRS, direction ratios, of AB line means axis is equal to 2, 1, -2. Okay. Now next, here we take the A is a vertex. Let A in bracket 1, -1, 2 with a vertex of the cone okay, and P be the any point on the surface, on the cone. Okay, therefore the DRS of AP line is equal to X -1, Y minus, and here minus plus, and Z -2. Okay, now theta is given. Theta is 45 degree. Okay, for calculating right circular cone, it requires the three things. The first is DRS of axis, then second is DRS of generator, means DRS of the line AP, and third one is angle. Okay, if we know these three things, then we can write the equation of the cone. Then equation of the right circular cone, cos theta is equal to, see here, we have the formula. Cos theta is equal to, okay, DRS of axis into DRS of AP in terms of addition and divided by their magnitude. That is, theta is equal to 45 degree is equal to, now here the DRS of axis is 2 into X -1 plus 1 into Y +1, and here -2 into Z -2, and divided by the magnitude of the axis, that is 2 square, 1 square, and here plus -2 square. Keep the minus sign in bracket. Okay, be careful here. And here DRS of magnitude of the generator, X -1 bracket square, Y +1 bracket square, Z -2 bracket square. Okay, and we know here the cos 45 is 1 upon √2 is equal to. Now first we simplified the variable term and then constant. Here 2x, here 1y means simply y, and here -2z. Now here -2, and here -2 into -2 plus 4 and -2 plus 2 and 1, that is simply 3. Now here 2 square is 4, 1 square is 1, -2 square is 4, 4 plus 4 plus 1, that is square root of 9. The square root of 9 is 3. Okay, and now keep this bracket as, keep the square root term as it is, X -1 bracket square, Y +1 bracket square, Z -2 bracket square. Okay, now we simplified here the denominator of both sides multiplied to the numerator, the 3 into square root term multiplied to the 1, and √2 is multiplied here. So we get 3 into 3 into under root term, x minus 1 bracket square, y plus 1 bracket square, and z minus 2 bracket square, okay, is equal to root 2 into 2x plus y minus 2z plus 3. Okay, now squaring both sides, then we get here the square of the 3 is 9, and here square and square root cancel, that is x minus 1 bracket square, y plus 1 bracket square plus z minus 2 bracket square is equal to, the square of the root 2 is simply 2, and here 2x plus y minus 2z, okay, and plus 3 its square. Now simplify the left hand side. 9 into, this is a minus b bracket square, is a square minus twice ab plus b square, that is x square minus 2x plus 1, y square plus 2y plus 1, and here last z square 2 times ab minus 4z plus 4, bracket complete. Now here is equal to here a plus b plus c plus d bracket square. Here I'm writing simplified form, that is just right here. Okay, that is a plus b plus c plus d bracket square is a square plus b square plus c square plus d square plus, now 2 times a vary with b c d, that is 2 times ab, 2 times ac, 2 times ad. Now plus 2 times, now b is vary, bc, 2 times bd, now c is vary, plus 2 times c into d. Okay, so here 3 term, here 2 term, here 1 term. Okay, now see here, this is a, b, c and d. So simplified, keep 2 as it is. Now here 4x square plus y square plus 4z square plus 9. Now 2 times ab, that is 4xy, 2 times ac, 2 into 2 4, 4 into 2 8, minus 8 minus 8 xz. Now 2 into 3 6, 6 into 2, that is 12x. Okay, see here, x square plus y square plus z square plus d square. Now 2 times ab minus 2 times ac, 2 times ad, this is xz. Okay, now plus 2 times bc, 2 times bc means what, that is minus sign is there here, this is here minus 8xz, and here 12x, and here minus, okay, 2 times bc, that is minus 4yz, and here 2 times 3 into 2 6 y. Now last 2 times cd, that is 2 into 3 6, 6 into 2 12, 12z. Okay, now last step, we construct the first x square y square z square, then 2 variable term, now then single term, and then constant. Now 9 is multiplied here, 9x square and plus here 8x square, the plus 8 square in left hand side it become minus 9 minus 8, that is simply x square. Now here 9y square and here 2y square, 9 minus 2 7 plus 7y square. Now 9z square and 2 into 4, 8 minus 8, that is plus z square. Okay, we finish a square term. Now 2 variable term, in left hand side there is no 2 variable term, in right hand side 2 variable term. 2 into 4, that is minus 8xy, 2 into 8 16, minus 16, that is it become plus 16 xz. Now here minus 4 into 2 8, that is plus 8 yz. Okay, now 2 variable term is finished. Now construct the x. 9 minus 8 into means what? 16 minus 9 into 2 minus 18. Okay, and here x term is okay, here 12. 12 into 2, 24. It become minus 24. Just wait. This is 9 into 2, 18. 18 and this 12x. X. Minus 42x. Now construct the y. Y here 2y into 9, that is 18y, and in left hand side y is here. Now here 6 into 2, now 12 minus 12. Okay, that is plus 6y. Okay, now last construct the z. Now here minus 4 into 9 minus 36, and here 12, and this 2 minus 24, minus 24, it become plus 24. 24 minus 36 and plus 12, that is minus 12z. Okay, now construct the constant term. First we construct the constant in bracket. 1 plus 1 2, 2 plus 4 6, 6 into 9, 6 into 9, 54. Now here construct the constant term. There is only one constant term in left hand side. Into 18, 9 into 2, 18 minus 18. So here plus 36 is there, is equal to 0. Okay, so which is required equation of right circular cone. Thank you. Thanks for watching video.